Okay, introduction to nonlinear circuit analysis. So, a classification of problems of analysis and then typical nonlinear elements that will create our circuit. So, generally, our nonlinear element can be classified as bilateral nonlinear element, like here in blue. Bilateral means this in this quadrant, the function in this, in this first quadrant, function is exactly the same as a function in a third quadrant. Or we may have a unilateral nonlinear element, the so-called non-ohmic element, and this exemplary characteristic is given here. So nonlinear element can be bilateral or unilateral. Now a few typical elements of electronic or electrical circuits. Let's start with a light bulb, a filament lamp, and its UI characteristic. It is a schematic description, and UI this time on vertical axis voltage, on horizontal axis current. As you can see, actually for low we have low dynamic resistance for low values of voltage. Then we have this green segment is the segment that operating point should be located at, and then we have a blue segment, and obviously at this area is forbidden because the power is greater than nominal power of the filament lamp. If we exceed this power, then obviously we will burn our filament and we will destroy our bulb. So this is a typical nonlinear element, bilateral nonlinear element. Now unilateral nonlinear element, diode, and then Zener's diode. So this is a relationship for an ideal diode. It is a schematic description, and in blue we have an ideal diode. We may distinguish two segments: a forward polarization, U is equal 0, current is greater than 0, and then inverse polarization, which is I equals 0 and U less than 0. So this segment is just a short circuit, and this segment is just an open circuit. This is an ideal diode. Then for practical diode we have slightly different. Actually, for inverse polarization it is nearly as we have had for an ideal diode. For forward polarization it is slightly different. I mean, we have this forward voltage. Instead of 0, we have a forward voltage of practically 0.7 volt for silicon diode. It is 0.7. So a practical diode, it is an open circuit for inverse polarization, and it is a voltage source of 0.7 volt for silicon diode for forward polarization. The special case of diode is Zener's diode. Zener's diode has exactly the same characteristic in the first quadrant. In the third quadrant, it is the same up to some voltage, which is called Zener's voltage. This is Zener's voltage. And at this voltage, we have a fixed value of voltage regardless the current, obviously up to some maximum current. This is once again forbidden area, as the power is above the nominal one. So this is Zener's diode. And finally, a classification of nonlinear circuits and approaches to nonlinear circuit analysis. So we may say that nonlinear circuit is a homogeneous nonlinear circuit. Homogeneous means all elements are nonlinear and of the same character, same kind. This is the case of pneumatic or hydraulic circuit. Also magnetic circuit are homogeneous nonlinear circuits. Then we can have non-homogeneous nonlinear circuit, which means only some elements are nonlinear, and these nonlinear elements are normally, as in electronic circuit, are diodes and transistors. Also in magnetic circuit we may have a non-homogeneous circuit if we have an air gap, which is a linear element on a circuit diagram. Then approaches to nonlinear circuit analysis. Nonlinear circuit is described by the system of nonlinear equations based on Kirchhoff's laws and there is no Ohm's law. There is IE relationship describing nonlinear element or elements. Then the first approach, which is applicable to a simple circuit, is this graphical approach, graphical analysis. Then for more complex circuits, but still quite simple, let's say 10, maybe 20 elements, not more, we may apply a piecewise linear approximation-based approach, metoda aproximacji odcinkowej, and the method which is commonly used in simulators in PSpice, for example, it is iteration-based method, Newton-Raphson iterations-based analysis. So we will discuss these three analyses. We will skip this one, which is applicable only for computer calculations, and graphical analysis and piecewise linear analysis will be discussed later on, and for now on, that's all.